All right, team, we are going to do some quick test here for Jonathan to continue the presentation. Try to join from another computer in a way that, I just want to make sure first you are able to see the screen, which is the first slide, which says Rural 5G Changing the Environment. Can you see that?
Yes.
Sure, this is good.
Yes, Carter.
Perfect, thank you very much. And let me quickly come here. Jazz, please feel free to introduce Jonathan, but before that, let me do a quick test here. I'm going to put Jonathan in the speaker phone I'm going to keep my phone next to the speaker phone here, and I trust you are able to hear. Jonathan, can you a little bit speak so that I can?
Yeah. Hello, everyone. It's good to be with you today.
Thank you. One sec, Jonathan. Can you hear us? Can you hear Jonathan, everyone?
It's a little bit cold. Yeah.
It's a little bit low.
But it was breaking.
Was it? Okay. It's going to be interesting. Let me see if I can do a little bit different here. Just a minute. Find. Can you guys still hear me?
Yes.
Okay. Jonathan, can you speak now, please?
Yep. Hi, everyone. It's good to be with you today. Would let us know if you can hear my voice okay?
This is definitely better.
Is it better?
It's definitely better, yeah.
Sure.
Much better now.
I need your help to come down and do the screen for me, please.
Yeah.
All right, Jonathan, please go ahead.
Okay, so it is my privilege to introduce Jonathan Black, Executive Director of Canwisp, Canadian Association of Wireless Internet Service Providers, and an advisor to ISPs across the country. Canwisp's members provide broadband internet to Canadian homes and businesses utilizing fixed wireless technology. In this role with Canwisp, Jonathan represents the industry to the CRTC at Innovation, Science and Economic Development Canada on matters such as equal access to government funding, spectrum and industry regulation. Outside of his involvement in Canwisp, Jonathan has held senior operational, advisory, and financial roles in various technology and software companies. Jonathan lived the upside of the internet bubble in the venture capital and learned more difficult lessons working inside an internet startup when the bubble burst. Jonathan, please take it away.
Hey, everyone. Thank you all for inviting me to speak today. I hope this session is interesting and provides some material for you. I think the technology issues that we're having today are an example of why open source software and open source 5G tool set could be incredibly valuable and could in fact change the environment in which we live. I'm outside of Toronto, about an hour north of Barrie, and I don't have sufficient data service on my phone to be able to connect with you by video or even to share a video presentation. So that underscores the importance of the work that you're doing in the test offer community. So just next slide. Very quickly today, in the next few minutes, I'm going to give you a quick understanding of the WISP marketplace, both the definition of a WISP and of the industry in general. I'm going to fly through a 5G overview from my perspective. Some of you may be 5G experts. I will give you a heads up that this presentation, I took some slides from a presentation I made to ISED when we were explaining to them what 5G was about. ISED being the former Industry Canada, has some very technical people, but not the ones I speak to are more on the regulatory. So, next slide, definition. So a WISP is a wireless internet service provider. They use wireless connections for the last mile, and these are fixed connections, but not mobile. So if you're driving down, a highway, a major highway, your data service is moving from cell tower to cell tower as your phone moves down the highway. These ISPs called WISP do not use mobile technology. They actually attach an antenna to the roof of your house and make a connection to a land-based, not a satellite, to a land-based distribution network. So these tower locations, every third or fourth one will be fiber connected back to a NOC. And I should also clarify that a tower isn't necessarily a telecommunications tower that's 300 feet tall that you're used to seeing. It could be some RF equipment on a farmer's silo in their field, in a small community, or on top of a community center in a very small village or town. As I mentioned, the requirement to have an antenna on the customer's location. And typically, these networks are deployed in rural or slightly rural areas where population density, the household density, is not sufficient to support a fiber-based installation. On the next slide, I have a very, maybe a hard-to-see graphic that represents how a WISP would operate. So you can see the cloud there. That's the internet cloud. The WISP office will be connected to the cloud or possibly through an internet exchange point or a carrier hotel. There will be a fiber connection from that location to a tower. And on that first tower, there's going to be distribution of the internet signal to customers' homes or businesses. As well, it would go out wirelessly by a point-to-point solution to another tower location. Again, out to more customers' antennas on businesses or homes, and then possibly out to another transmitter location on another tower. So you can see there that there are multiple wireless connections point-to-point and multiple point-to-multi-point wireless connections as well. Next slide. So Canwisp, as an association, was founded in 2013. A small group of WISPs came together, and really it was to promote, share best practices, and to work with spectrum regulators and funding sources. Today we're about 60 WISP members. On the next slide, the WISP market is surprisingly large. There are about 250 WISPs in Canada. Most of them are small and medium enterprise. They're locally owned, they're private, often family owned, and they would serve between 200 and 30,000 subscribers. If you're running an ISP that serves 200 subscribers and you assume that there's $80 a month in revenue, that ISP is bringing in $200,000 a year in gross revenue. That's before any costs or expenses are taken out. That's a very small business.
That's just slide, please.
Thank you. So many of these small ISPs are now starting to install fiber to the home. Technology that they're deploying for the RF portion, the wireless portion, is predominantly it's from a number of providers, whether it's Cambium Networks or Telrad. And often these are proprietary protocols. A few of them have deployed some LTE technology, and at this point, very few, if any, have deployed 5G. 5G is an incredibly expensive technology to deploy at this point. On the next slide, we won't spend much time on this, but again, as this slide was used in a presentation to some Industry Canada people, we just wanted to compare the various technologies. On the next slide, a bit more technical, 5G, from my perspective, it's really a collection of technology advances on the RF side and on the software side. It uses two spectrum bands to achieve the incredible results that it brings. The other aspect of 5G is that in order to get all of the benefit of 5G, including mobile connectivity, you really need every piece of equipment to be fiber connected. To go from point to point on a wireless connection is not fast enough for the 5G network to deliver its full capability. On the spectrum or the frequency physics side, I mentioned two spectrum bands, a high band, a millimeter wave from 12 gigahertz to 60 gigahertz. Very briefly, the higher the number, the faster it goes, the more data it can carry. But also, the closer the antennas need to be to each other. The lower the numbers, so 6 gigahertz, obviously smaller than 12 gigahertz. It's a much more reliable service. It's unaffected by weather. It can go through trees and walls. It does not go through bedrock. But the connection, it can go further as well, further distance. On the next slide, the implications here are that in order to use those higher frequencies to give the super fast and super high bandwidth, the access points, those distribution antennas need to be very close together, about 500 meters, about the distance that they will effectively give a signal. And again, we mentioned that each of those distribution homes needs to be fiber connected. And really, this is not feasible for most widths. There's two reasons for that. One of them is a business reason. If you're serving 5 or 10 homes in a 1 kilometer radius around an antenna, do the math very quickly. 5 or 10 homes times $60 to $90 a month times 12 months. Cost of installing equipment, buying a core, and getting fiber connectivity, and you can't really ever pay that back. The other part is when you're a small WISP, you don't have a small ISP, you don't have access to the funding resources that a major carrier does. So really they are looking at other solutions today because the 5G networks are very expensive. On the next slide, really this is where I think the challenge provides a possibility. So if there's a way to reduce the cost of a product, or if there's a way of reducing the cost of providing or access support, those could change the environment. Those could be game changers. I can sit here with my Canwisp hat on and talk about how it would be a game changer for small islands. Or if I take my Canwisp hat, really the more cost-effective 5G can be, more Canadians, more international ISPs may be able to deliver service to less densely populated areas. And really, when I do take my association hat off in the end, that's the goal here, is to see that more of the world's population is connected to fast, reliable internet. And that could be a huge game changer. On the other side, you minus costs, and you need to have profit at the end of the day to continue your investment, continue your business. Maybe new IoT applications that could use 5G technology. The classic example, one of the major manufacturers a few years ago did a test in the Niagara region with a vineyard. They installed some 5G technology and monitored everything from the temperature of the crop across the various some additional product production out of that crop. I don't know how effective financially that was. It was a really interesting demonstration. The other possibility here is in rural areas where the mobile service is not as effective as it could be. Maybe there's a way that the core software that's being written could do an effective mobile handoff in the various sort of major carriers and minor carriers, smaller ISPs. The smaller ISPs, let me give you an example. There's an ISP in Ottawa. They serve about 3,000 customers, 5,000 customers from about 200 tower locations in Ontario. Those are all fixed antennas. And approximately 10 to 12 of those towers are fiber connected. The rest of those towers are connected by a point-to-point wireless connection. That would be a somewhat typical medium to large size wireless ISP. their towers are in locations where the mobile internet service, mobile cell phone service is weak. If there's a way to leverage their investment in tower locations with an effective or cost-effective core, maybe there will be a day when the carriers, the major cell phone carriers and the smaller ISPs could work together and deliver better mobile internet, better phone service across the country and around the world. Really, my comments in those of you who are more cost-effective code. Now, don't let 5G be about only fast.
Jonathan, there is some challenge with respect to the voice. You're breaking now, please.
Okay.
Yeah, now it's okay. Yeah. So the last word that we heard from you was, there's some way to collaborate together, right? The WISPs as well as the operators. Yeah,
okay.
please.
So really, possibly by lowering the cost or increasing some of the revenue, maybe there's a way that the small ISPs and the major carriers could collaborate, possibly a mobile handoff between their locations, and offer better, more effective cell phone and internet service across the country and around the world. Really, my wish for you all is that as you design 5G software, that you don't only make it about faster internet for those who already have it in major cities in Toronto and in Vancouver, but if you can impact the way 5G is applicable and are more cost effective in rural areas where the population is less dense, that could be a game changer. That could change the environment. Thank you all for your time today. If we have time for questions, I have the time for a few questions. Alternatively, on the next slide, I've included some resources on internet coverage across the country. And on the final slide is my email address and phone number. If you have any questions that we can't get through today, please feel free to reach out. Thank you.
Wow, we made it, Jonathan. We made it. I really hope that you guys were able to hear it. I know that there were some disturbance in between, kids shouting, and hopefully, you were able to get across the message what Jonathan was able to communicate. Can I get some comments around that, please? Okay, I get lots of claps here. Wow, it was like a real fun, right? But we made it happen. Thank you very much, everyone, for your patience, for all these technical difficulties. Thanks again, Jonathan. You are right? You're just an hour away from Toronto, and we have this challenge. So it's basically a message for all of us. In fact, Jonathan, we were talking about, you talked about the low-cost core. And in fact, we had Phil presenting us zero-cost core today, right? Magma, Facebook Magma core. And, IBM from Ashek, he was talking about AI and analytics. Maybe, together with this new initiative that we have been venturing into, which we call it as the Decoding 5G Zone with the community within the Testoper, work together with Canwisp and Phil and even Ashek to see how we can improve this connectivity challenge. So next time when you go an hour outside of Toronto, you are able to show yourself in the video and able to present to all of us.
That would be wonderful.
Interesting, but I'm happy that we made it work. Thank you very much, Jonathan. I will let you go, and if there are any questions, I will follow it up with you and get the answers, and then respond it back to some of the attendees. And we had likewise number of other questions that we could not really address. We will definitely address them, and we will follow it up with you to ensure all the questions are answered. So we'll continue on with the program. Jonathan, I'll disconnect the call and we'll continue on this. Thank you all. Thank you all. Just give me a minute so that I can quickly set myself back to the same situation as I was to continue rest of the session. Just hold on for a minute. All right, we are back. Can you all hear me, please?
Yeah, Carter.
Yeah.
Okay, so we have
Yes.
and all the four speakers have talked about their topics. That's really awesome, even though there were some challenges, but we made it work. So now we are getting into announcements, survey, prices, and networking. And then we are getting into this decoding 5G zone discussions. So let's have give an honor to our wonderful facilitators of the program, Jaspreet, Tanisha, and Navneet, to close this session. Please go ahead.
Yeah, so like you said, just brings us back to the end of our main program. Thanks everyone for joining today's session. We'd like to also thank our speakers, Kader, Phil, Ashik, Anes, and Jonathan, and the Testoper volunteers who worked hard to make this event happen. Thank you so much again. Attendees, we seriously trust that you learned great insights and had a wonderful time together with us as well. And we cannot wait to see you in our next program and join us as volunteers to advance the massive transformation purpose of our community.
Imad, can you shut your mouth, please?
Out of that.